some logs to deal with here, and we're told that x and y are positive. We're first asked to write down, this is part A, log of x to base y is equal to z, and show that log to base y of x is actually 1 over log to base x of y. So we're going to have to undo the logs and try and take x as the base. Now if we undo this log, then it's going to be that x is equal to the base to the power of z. Now I kind of want to get it so it's x to the power of something, and I can do that because it's going to be x to the power of 1 over z is equal to y. There's a couple ways you can think about it. Maybe like, if you squaring is the opposite of square rooting, so raising to the power of z is the opposite of raising to the power of 1 over z. So I've thought about it in terms of inverse operations. Or you can imagine raising both sides to the power of 1 over z, and it would cancel out over here to just leave you y to the 1. It would stay over here. So that means now that log to base x of y is 1 over z. What do I raise x to the power of to give y? It's 1 over z, okay? Just using the properties of logs. And therefore, z is going to be 1 over log to base x of y. I've just sort of taken the reciprocal here. Hence, log to base y of x is equal to 1 over log to base x of y. That's a result worth knowing, in fact. It's a nice result. In part B, we're told that also they're actually the same thing, and hence to show that y is equal to 1 over x. So if they're the same thing, then I can multiply them, I can basically replace this by log to base y of x and times through. And that must equal 1. And hence log to base y of x must equal plus or minus 1. Let's look at these two cases. If it's equal to 1, then it must be that y is equal to x. Now, right at the start, we had that x was greater than y. Let's look at the second case. Well, it actually directly follows from here. Maybe I should write x to the minus 1 first. If you want an extra step, then you could have written minus log y x is equal to 1. So log to base y of 1 over x, using the third order of logs, taking the reciprocal, is 1. And from that we get y equals 1 over x. So that's, if you prefer a little bit more working, then go with that. We are asked to prove it, so I feel like we can go straight from here to here, but this would be a little bit more reasoning. On to part C. Now we have some simultaneous equations to deal with. Remember, we still have these results from before. Okay, first up is that we have this, these are equal, and this implies that y is equal to 1 over x from part B. And therefore, I can replace y by 1 over x in the right-hand side over here. Do you know what? I can replace all of it actually, can't I? I can just get an equation in terms of x. Now, a result worth knowing is that log to base x of a is equal to log to base 1 over x. Sorry, I'm going to log to base 1 over x of a is equal to log to base x of 1 over a. You can basically flip them round. Now let's just prove this. So let's call this z. That would imply that 1 over x to the z is equal to a. Hence, x to the minus z equals a. Hence, log to base x of a is equal to minus z, which means that z is going to be minus log to base x of a, which is going to be log to base x of a to the minus 1, which is 1 over a. So basically I've just proven it. I've proven that this thing here is the same as this thing here. And therefore, log to base x of x minus 1 over x will equal log to base x 1 over x plus 1 over x. And we can undo the logs. Multiply through. It's sort of a difference of two squares. It's going to be x squared minus 1 over x squared is equal to 1. This is going to be a hidden quadratic. I can multiply through by x squared. I've minused 1 first, and then multiplied through by x squared, and then times this by x squared. Okay, that's actually not going to factorize, so let z, do I want to use the word, yeah, I can use z. Let z equal x squared, then I've got z squared minus z minus 1 is equal to 0. So z is going to be b plus or minus b squared minus 4ac but remember we need, actually let me go with so x squared will equal 1. It's got to be plus root 5 over 2. First of all, we're squaring it, aren't we? X squared will be positive. That's all we actually care about. So x and also x is greater than 0. So we only need to take the positive root. X will be 1 plus root 5 over 2 square rooted. Ignore the negative. And y, remember, was 1 over x, so we can just flip it round. It's going to be 2 over 1 plus root 5 square rooted. There we go. Just to say, I should have said this before, if you didn't know this result that I used, where's it gone? Here, to like flip it round. Of course, you could, you could just call this thing z, and then write that it's going to be z to the power x is equal to x minus 1 over x. And then that thing is z as well. So z to the 1 over x is equal to x minus 1 over x. And kind of gone from there. Eliminate eliminate z from the equation, and you would have got the same thing. So I just wanted to say that. It is worth knowing this, to be fair, but if you don't, there's always, there's ways around it. You can get to results in multiple different routes.